The F8F Bearcat was one of the most powerful piston engine fighters developed by the United States during World War II. Designed by Grumman, it was introduced very late in the war, officially entering service in 1945. Because of this timing, the Bearcat missed the major combat operations of World War II, including crucial battles in the Pacific theater. The aircraft was known for its exceptional speed, maneuverability, and climb rate, qualities that made it arguably the best piston-driven fighter ever built by the U.S. Navy. But what if the F8F Bearcat had arrived earlier, specifically in 1944? This hypothetical scenario raises fascinating questions about how the course of aerial warfare, and even the Pacific campaign, might have been altered. In 1944, the U.S. was deeply engaged in island-hopping campaigns, battling Japanese forces in fierce aerial combat. At that time, the primary naval fighters were the F8F Hellcat and the F4U Corsair, both excellent in their own right but facing increasingly capable Japanese aircraft such as the Nakajima Ki-84 and the Mitsubishi A6M50. The Bearcat's superior speed and climb rate could have potentially outclassed these adversaries. With earlier deployment, U.S. naval aviation might have enjoyed air superiority even more decisively, reducing American pilot casualties and shortening battles. This would also have implications for the final stages of the war, including the Battle of Leyte Gulf and the strategic air raids against the Japanese mainland. Furthermore, the Bearcat's arrival in 1944 could have influenced the tactics used by the U.S. Navy, shifting the emphasis toward faster, more aggressive dogfighting styles that leveraged the Bearcat's strengths. This analysis explores the technical capabilities of the F8F Bearcat, the state of air combat in 1944, and the broader strategic consequences if this legendary fighter had arrived sooner on the battlefield. The F8F Bearcat was a game changer in terms of technical specifications compared to fighters in active service during 1944. Powered by a Pratt & Whitney R2800 double Wasp radial engine, it generated about 100 horsepower, pushing the Bearcat to speeds exceeding 420 ft. This made it one of the fastest piston engine fighters in the world at the time. Its light airframe and aerodynamic design contributed to an outstanding climb rate of around 4,000 feet per minute, which was significantly better than its predecessor, the F8F Hellcat and the F4U Corsair. These performance advantages meant the Bearcat could engage or disengage combat at will, providing pilots with tactical flexibility not available with older aircraft. In 1944, the main adversaries were the Japanese Nakajima Ki-84 Frank and the Mitsubishi A6M50, both highly maneuverable and fast but generally inferior in raw speed and climb. The Bearcat's heavier armament of 420 mm cannons also gave it superior firepower. If the Bearcat had been deployed in 1944, it could have dominated dogfights with faster interception and more effective strikes, allowing U.S. pilots to control the skies more efficiently. This superiority would have reduced pilot losses and increased mission success rates, further boosting the morale of U.S. naval aviators and potentially shortening the war in the Pacific. Introducing the F8F Bearcat in 1944 would have altered the balance of air power in the Pacific theater. The period was marked by intense air battles over strategic islands like Saipan, Polilliu, and the Philippines. The U.S. Navy's F8F Hellcat and Marine Corps' F4U Corsair were dominant but sometimes challenged by newer Japanese aircraft. The Bearcat's combination of speed, climb, and armament could have turned these engagements in favor of the Allies even more decisively. For example, during the Battle of the Philippine Sea in mid-1944, often called the Great Marianas Turkey Shoot, U.S. forces destroyed hundreds of Japanese planes with relative ease. However, with Bearcats present, American pilots could have pursued retreating Japanese aircraft more aggressively, reducing the enemy's ability to regroup or counterattack in subsequent battles. The Bearcat's agility and climb rate would have helped intercept Kamikaze missions earlier, potentially saving many Allied ships and lives. Its presence might also have influenced Japanese tactics, forcing them to rely more on ground defenses or shift to night operations, weakening their overall air strategy. Thus, the Bearcat arriving a year earlier could have reshaped not only the outcomes of battles, but also the strategic approach of both sides in 1944-45. The Battle of Leyte Gulf, fought in October 1944, was one of the largest naval battles in history and a pivotal moment in the Pacific War. It involved massive carrier airstrikes, surface engagements, and amphibious landings. If the F8F Bearcat had been operational during this battle, it could have made a significant difference. The Bearcat's speed and firepower would have enhanced air cover for U.S. carriers, allowing pilots to intercept Japanese bombers and fighters more effectively. This might have prevented or reduced damage to key American ships and helped maintain naval dominance. Furthermore, with Bearcats, the U.S. Navy might have launched more aggressive offensive air operations against Japanese surface fleets, potentially sinking or disabling more enemy vessels. The Bearcat's performance would also have reduced pilot fatigue and losses during prolonged engagements, as its ease of handling allowed for quicker turnarounds between sorties. Overall, the earlier introduction of the Bearcat in 1944 might have contributed to a more decisive Allied victory at Leyte Gulf, accelerating the liberation of the Philippines and hastening Japan's eventual defeat. The Bearcat's arrival in 1944 would not only have meant better hardware, but also influenced naval aviation tactics. Its outstanding climb rate and speed encouraged a hit-and-run approach, different from the more methodical dogfights typical of the Hellcat. Pilots could climb rapidly above enemy planes, dive to attack with surprise, and disengage before the opponent could react. This tactic leveraged the Bearcat's strengths perfectly, enabling greater pilot survivability and mission effectiveness. Additionally, the Bearcat's maneuverability at high altitudes would have improved performance during escort missions for bombers attacking Japanese targets. This could have increased the success rates of such bombing campaigns by reducing enemy interception. The Bearcat's presence might also have pushed training programs to emphasize vertical combat maneuvers, preparing pilots to exploit their aircraft's capabilities fully. These tactical shifts would have likely reduced the duration of air battles, improved kill ratios, and altered the pace of air warfare in 1944 and beyond. Had the F8F Bearcat been introduced in 1944, it could have played a crucial role in the air campaigns over Japan itself. By late 1944, the U.S. had started launching strategic bombing raids on the Japanese home islands, relying heavily on long-range escort fighters and carrier-based planes to protect bombers from interception. The Bearcat's superior speed and firepower would have strengthened these missions, allowing U.S. pilots to reach targets faster and deal with enemy interceptors more decisively. It also could have disrupted the effectiveness of Japan's air defenses, including the notorious Kamikaze attacks that intensified in 1945. By intercepting Kamikazes earlier, Bearcat pilots might have saved countless lives and naval vessels. Moreover, the psychological impact of facing such a formidable new fighter could have further demoralized Japanese air forces. These factors combined suggest that the Bearcat's earlier deployment could have accelerated the air war's conclusion, reducing Allied casualties and damage while increasing pressure on Japan to surrender. In 1944, the F6F Hellcat and F4U Corsair were the backbone of U.S. naval aviation, widely respected for their ruggedness and combat effectiveness. However, the F8F Bearcat was designed as a lighter, faster successor to both, while the Hellcat was known for its durability and ease of maintenance, and the Corsair for its speed and range. The Bearcat combined the best of both worlds, but added remarkable climb rates and agility. The Bearcat's smaller size and lighter frame made it less of a target, and it could out-climb and out-run many adversaries. If introduced in 1944, it likely would have gradually replaced Hellcats in frontline squadrons or served alongside Corsairs, providing tactical options that were unavailable at the time. This combination would have further strengthened U.S. air power by allowing commanders to assign Bearcats for air superiority missions, Hellcats for ground support and rugged operations, and Corsairs for longer-range strikes. The net effect would have been a more versatile, lethal naval air force, able to adapt quickly to shifting battlefield conditions in the Pacific. One of the most serious threats to the U.S. Navy in 1944-45 was the Kamikaze suicide attack. Japanese pilots deliberately crashed their planes into ships, causing devastating damage. The Bearcat's arrival earlier could have dramatically improved defense against this tactic. With its faster climb rate and excellent acceleration, Bearcat pilots could intercept Kamikaze attackers at greater distances from the fleet, disrupting their attack runs before they reached American ships. Its powerful armament would have been effective in quickly destroying incoming planes. Improved interception capabilities could have reduced the number of successful kamikaze strikes, saving lives and preserving critical naval assets. The Bearcat's early presence might have also allowed better pilot rotations and reduced fatigue, leading to more alert and effective defense during prolonged kamikaze raids. This advantage could have changed the nature of late war naval engagements, tipping the balance further in favor of Allied forces. Amphibious assaults were crucial in the Pacific War, allowing the U.S. to gain footholds on strategically vital islands. Air support was essential to protect landing forces and suppress enemy defenses. The F8F Bearcat's arrival in 1944 would have enhanced this capability by providing faster, more precise close air support and air superiority over landing zones. Its speed allowed rapid response to threats, and its firepower could target enemy fortifications, artillery, and troop concentrations effectively. Faster fighter patrols would have maintained continuous air cover over beaches, reducing enemy counterattacks and supporting the success of operations such as the Mariana and Philippine campaigns. This improved air-ground coordination could have shortened battle durations, lowered casualties, and hastened island capture, ultimately accelerating the Pacific campaign's progress. While the Bearcat had clear performance advantages, its introduction in 1944 would have posed challenges for pilot training and adaptation. Pilots accustomed to the Hellcat or Corsair needed time to master the Bearcat's unique flight characteristics, especially its high power-to-weight ratio and rapid climb. Training programs would have required acceleration to get Bearcat pilots combat-ready without compromising safety. This transitional period might have slowed initial deployment effectiveness, but was likely short-lived given the aircraft's intuitive handling and pilot-friendly controls. Furthermore, the U.S. Navy's training infrastructure was highly advanced by 1944, capable of rapidly preparing skilled aviators. Once mastered, pilots would benefit from the Bearcat's superior capabilities, gaining confidence and combat effectiveness. Overall, while training posed a short-term hurdle, the long-term payoff of earlier Bearcat deployment was significant. If the F8F Bearcat had arrived in 1944 and demonstrated its capabilities in combat, it might have influenced post-war fighter development differently. The Bearcat was the pinnacle of piston engine fighters just before the jet age, and its performance set a high benchmark. Earlier combat experience could have accelerated design lessons incorporated into early jets, such as the F9F Panther. The Bearcat's emphasis on speed, climb, and agility would have pushed designers to prioritize these traits in early jet fighters, possibly influencing U.S. naval aviation strategy and technology in the late 1940s. Additionally, combat data from an earlier Bearcat deployment might have informed tactical doctrines, emphasizing rapid vertical maneuvers and hit-and-run engagements in the jet age. The legacy of the Bearcat could have been stronger and more directly linked to the transition from piston to jet fighters. Introducing the F8F Bearcat in 1944 would have required overcoming significant logistical and production challenges. The Bearcat was developed late in the war to replace aging fighters, and ramping up manufacturing early would have meant diverting resources from existing planes like the Hellcat and Corsair. Production lines would have needed rapid retooling, and parts supply chains would have had to expand quickly. Additionally, maintenance crews required training to support the new aircraft's unique systems. These factors could have delayed the Bearcat's full operational availability despite its superior capabilities. However, the U.S. industrial base during World War II was highly efficient and capable of scaling up production when necessary. With priority, the Bearcat might have reached frontline squadrons sooner, influencing key 1944 battles. The benefits of superior performance would have likely outweighed initial logistical hurdles, accelerating combat effectiveness as crews and pilots adapted to the new fighter. The early arrival of the F8F Bearcat would have had psychological and strategic effects on Japanese air forces. Japan was already struggling to keep pace with American technological advancements by 1944, and facing an even faster, more agile fighter would have worsened the situation. Japanese pilots might have faced increased losses and declining morale as Bearcat pilots dominated dogfights with superior speed and firepower. This could have led to shifts in Japanese tactics, possibly emphasizing defensive strategies, night fighting, or kamikaze missions earlier. However, such adaptations were reactive and could not fully negate the Bearcat's advantages. The psychological impact of facing a seemingly unbeatable new fighter might have accelerated Japan's Air Force decline, hastening Allied air superiority and contributing to the overall collapse of Japanese resistance in the Pacific. Carrier warfare was the centerpiece of Pacific battles, and the Bearcat's arrival in 1944 would have significantly influenced naval tactics. Faster, more maneuverable Bearcats could have expanded the range and effectiveness of carrier strike groups. Their ability to climb quickly and engage enemies at higher altitudes would have enhanced fleet defense and offensive capabilities. Bearcat pilots could have more effectively protected carriers from enemy air raids and supported surface ships against air and sea threats. This might have allowed carriers to operate with greater freedom and confidence in contested areas, expanding U.S. naval reach. The Bearcat's presence would have also encouraged the development of new tactics, emphasizing rapid interception and dynamic air combat, making U.S. carrier groups more adaptable and lethal throughout 1944-45. Although the Bearcat was primarily designed for the Pacific, an earlier introduction in 1944 raises the question of its potential use in the European theater following D-Day. The Allies faced formidable Luftwaffe fighters like the Foch, Wolf 190 and Messerschmitt Bf 109, which continued to challenge Allied air superiority. The Bearcat's speed, climb, and armament might have provided a powerful new tool against these German fighters, supporting bomber escort missions and ground attacks. Its performance at low and medium altitudes suited the European battle environment well. While logistical focus was heavily on the Pacific, early deployment of the Bearcat could have offered additional flexibility to Allied air commanders in Europe, possibly shortening air campaigns and reducing bomber losses. This scenario, while less likely historically, highlights the Bearcat's broad potential impact on World War II air combat had it arrived in 1944. The question of what might have happened if the F8F Bearcat had arrived in 1944 remains a fascinating what-if in military aviation history. While the Bearcat was ultimately overshadowed by the dawn of the jet age, its late arrival deprived World War II of one of the finest piston fighters ever built. Had it been available earlier, it could have shifted the air combat balance decisively in favor of the Allies, reducing casualties and accelerating victory in the Pacific. The Bearcat represents both the pinnacle of piston engine fighter design and a symbol of missed opportunities due to wartime production realities. This hypothetical scenario invites reflection on how technology timing can influence history and how different outcomes might have unfolded with faster innovation cycles. For aviation enthusiasts and historians alike, the Bearcat story illustrates the delicate interplay between design, production, and combat effectiveness in shaping wartime success. One of the most crucial aspects of any fighter aircraft is how it affects pilot survivability and combat effectiveness. The F8F Bearcat, with its superior speed, agility, and climb rate, would have dramatically improved both factors had it been deployed in 1944. Its ability to dictate the terms of engagement, choosing when to attack or disengage, gave pilots a significant tactical advantage, lowering their risk of being caught in dangerous situations. The Bearcat's robust armament meant that pilots could inflict damage quickly and decisively, often ending dogfights before prolonged exchanges. This capability would have reduced pilot casualties and preserved experienced airmen, whose skill was critical to maintaining air superiority. Earlier Bearcat deployment could have contributed to higher mission success rates, greater confidence among pilots, and a more effective Allied Air Force in the crucial final years of World War II. Air superiority was vital for the success of Allied operations in 1944 and beyond, enabling safe naval movements and effective ground campaigns. The introduction of the Bearcat in 1944 could have accelerated the timeline for achieving uncontested Allied air dominance, especially in the Pacific. With Bearcats complementing or replacing older fighters, the Allies could have neutralized Japanese air resistance faster, minimizing losses during amphibious assaults and carrier battles. This advantage may have shortened campaigns, such as the Philippines liberation, or reduced the need for costly aerial bombardments by enhancing fighter escort effectiveness. Consequently, the Bearcat's earlier arrival could have hastened the end of hostilities by ensuring air superiority sooner and limiting Japan's ability to mount counterattacks. Although the Bearcat was among the last great piston engine fighters, it played an important transitional role in aviation history. Had it seen combat starting in 1944, the Bearcat would have set a high standard for fighter performance just before jets became dominant. This would have provided valuable lessons for pilots and engineers moving into the jet age, influencing tactics and design priorities. The Bearcat's emphasis on speed, climb, and maneuverability helped bridge the gap between propeller-driven aircraft and early jets like the F9F Panther and F8F Sabre. Early combat experience with the Bearcat could have accelerated pilot training for jets and informed improvements in jet fighter design. Thus, the Bearcat's impact extends beyond World War II, shaping the development of post-war air combat. In conclusion, imagining the F8F Bearcat arriving in 1944 opens a window into a fascinating alternate history. This powerful fighter had the potential to reshape aerial warfare in the final years of World War II, enhancing Allied air superiority, protecting fleets, and supporting critical campaigns across the Pacific and possibly Europe. Although production and timing realities kept the Bearcat from these pivotal battles, its legacy as one of the finest piston engine fighters endures. The what-if scenario underscores how technological innovation timing can influence warfare outcomes and historical trajectories. For military historians, aviation enthusiasts, and strategists, the Bearcat represents both a remarkable aircraft and a reminder of how even small shifts in technology deployment can ripple through history. Ultimately, the F8F Bearcat story remains a powerful testament to the interplay between design, innovation, and combat in shaping the course of war.